So we're putting these on.
So we have to put clean suits on.
Okay, sounds great. Oh, goggle up. Ah, yes.
We're going to be doing pieces and parts, and I hope you guys know how to edit it all together. There's a Coder 2
Okay.
and Coder 1.
Oh my goodness.
You definitely have laminar flow. That is all why it works.
Hey, it's me, Destin. Welcome back to Smarter Every Day. I have been saying this for quite a while now. I think some people believe me, some don't, but I'm just going to keep saying it because it's true. Film is back. Photos taken on film have a certain magic to them, and a lot of people really love it. And I am one of them. This journey started at the lab where I get my film developed, Indie Film Lab in Montgomery, Alabama. It's amazing. They taught us all about the film development process. Josh then hooked me up with Matt at Kodak, who invited me to Rochester, New York to see the gigantic facility that's been making film for over 100 years. In the first video, we learned how they made the backing, or the floppy part of the film. They took these plastic pellets and they put them in a grinder, and then they put them into a screw auger thing, and then heated up the film and then stretched it out. Now, the big thing we learned in that first video is about this thing called the accumulator. It allows them to accumulate material inside the assembly line, so to speak, so that they can stop at one end of the line and make a cut when they roll it up onto a big roll. So that allows the whole process to operate in a continuous fashion without ever stopping. Today, we're going to start the next step of the process. We're going to take those huge rolls of backing or support material that we made last time, and we're going to load them into a huge machine at a different building. The whole goal is to apply a light-sensitive coating to the top of that backer, and maybe this is where the word film comes from. I don't know. It's like a thin film of emulsion. Different kinds of film have different coatings. So for example, today at the Kodak facility, they're going to be making Ektar 100, which is known for its extremely fine grain and really good color saturation. So this is what we're going to make today. But before we start, I want you to think about something. If you were to create the factory that applies a thin light-sensitive coating to the backing, like whether it be acetate or estar, how would you make that factory? What would it look like? Would you use a squeegee to apply a film? What would you do? So what I can do is I can show you a visualization of the inside of your factory. Are you ready? It would look like this. Complete darkness. The reason is because any light that leaks into the process as you're manufacturing film would expose the film and ruin it. Isn't that interesting? So any machinery you make in this facility has to be able to operate in complete darkness with minimal human input. That's fascinating. Also, by the way, you're applying this coating wet and it has to be dried. And while it's wet, it's very fragile. If you touch it on the wrong side, you ruin it. So how would you make this facility? Kodak's solution to these problems is incredible. I got my hands on some engineering drawings and we made a 3D model of the coating facility and it looks like this. It is incredible. There is so much going on here and I'm very excited to show you how this works because it is awesome. Once you understand how this facility works, it makes shooting with film even that much more rewarding. So if you're in, let's get started by heading over to the film sensitizing division so I can introduce you to Dr. Jeffrey Hansen. Jeff is going to be our guide along the way. He's been doing this for over 30 years and I can't overstate how incredible it is that he gave us 2 days of his time to teach us how Kodak makes film. Jeff is one of the leading experts in the entire world at designing new photography films and manufacturing them, and as you'll see, he is great at breaking down complicated topics.
Okay, so Jeff's going to give us a little bit of a behind the scenes of the science behind film, right?
I am.
Okay, so we're about to learn from the master himself how this stuff works.
All my colleagues are going to let me not live that down. Right? All right.
So teach me, Jeff, how does this stuff work?
So we're gonna kind of walk into this slowly before we get there. So the first thing that you need to know is kind of about the dimensions of film.
Okay.
All right. So this is a cross section. This is an average human hair.
Okay.
So this is a cross section of human hair. It's about 60, 70 microns. Okay. So the support that we were talking about is down here, and it's 130 microns.
Okay.
And this film, this is actually swollen. So it's gelatin after some water is put into it. It's a lot thicker.
Okay.
But this is like 25 microns.
So it's very thin.
Right. So
this film right here is thinner than a human hair?
Oh yeah. Well, so again, 2 parts to the film. The support
Okay.
could be the thickness of a human hair. 130, that would be a very heavy, thick hair.
Okay.
All right. But let's say it's close to that dimension.
Okay.
The chemicals that we put on top of it, 15 to 20 microns. And you can see it's like half or even smaller the dimensions of a human hair.
Got it. I'm with you.
All right?
Okay.
So film has layers, and what's in those layers is extremely important, and that determines what kind of film you're making. As we talked about in the film development episode with Indie Film Lab, film emulsion consists of silver halide crystals suspended in gelatin. And yes, gelatin is the same type of gelatin that you've heard of that's made of animal bones. It starts like a powder like this. Kodak does something very similar, and then they melt it to create different mixtures. Color photography film is created by laying down different layers of this silver halide crystals mixed in gelatin. Some layers are designed to capture certain wavelengths and intensities of light, while other layers may be designed to filter out certain colors of light. By varying the chemistry and the sensitivity of each layer and cleverly stacking those layers in a certain order, Kodak is able to make those layers work together to record a full color image. To accomplish this, each layer has to have its own separate chemical makeup, which can be very complicated. Jeff walked me through how the chemistry works and how Kodak goes about making up the component parts of these layers from hundreds of different chemicals. I got to go in the basement and see the massive vats and cauldrons, as I call them, where they use various techniques to precisely control the size and shape of the silver halide crystals that they're growing. He showed me where they make what they call melts. These are precisely controlled chemicals that go together to be piped upstairs, where they control the flow rate, the viscosity, the temperature. It's amazing. The complexity of their record-keeping system and their control systems to track and measure every ounce of every chemical, it's just staggering. Jeff explained that even the diet of the animal they source the gelatin from affects the chemistry down the line, and they take this into consideration. There is so much to learn about this process. Dye couplers are just amazing. Jeff taught me so much stuff about the chemistry of film. It's incredible. I did not want to edit it out, but I wanted it all on the internet. So I put it all in a second channel video. There's a link in the video description. If you're a photographer like me, you're going to love that video. Go check out that link. But for now, let's constrain the problem a little bit. Let's say we're going to focus only on the mechanical application of over a dozen layers of this emulsion type stuff onto the backing. How do we do that? Look at it this way. We first unroll the backing that we made in the last video into the machine, we'll call it, and then we're going to coat several layers at once. At this point, it's wet, jiggly gelatin, so we're going to need to chill it and solidify it. And then we need to dry it to remove the water from it so it'll stabilize. We then coat the rest of the layers, and then we chill it and dry it again. And then when it's dry, we can finally wind it all back up. So let's jump back into our 3D model so we can see what this simple sounding process looks like when you lay it out in a factory. This is where you unwind, then you coat, chill, dry. And then for the second coat, you're going to coat, chill, dry, and wind up. You got it? Unwind, coat, chill, dry, coat, chill, dry, wind up. And there's a lot of magic making that all happen. So what I'd like to do is I'd like you to experience this the way I experienced it in real time. So when I first got there, I could feel a little bit of a time crunch, and that's because they said the line was about to start up. They were going to start the coating process, and you could actually see a part of it with the lights on. So I got really excited about that. So they were going to make a run of Ektar, and so we're going to get to go into the coater and see the machine start. Now, one thing about that is I didn't really know what was going on at this moment, and you might feel that when you hear my questions, but it doesn't matter because afterwards we're going to come out and Jeff's going to explain everything. So unwind, coat, chill, dry, wind up. We're going to skip the unwind process right now, but we'll come back to it.
So we're putting these on.
So we have to put clean suits on.
Okay, sounds great. All right.
All right, ready?
Yeah. Oh, this is so cool, man. It's green.
All right. There are floors that are what we call dark floors. And to just keep the people's eyes from having to adjust all the time as you go from one floor to another, this is just a reduced light intensity.
Got it.
So there's nothing special about the color other than it's not bright white.
Okay, so here's what I'm detecting already. This is a gigantic process. Jeff knows what's happening. We're trying to figure out where they're at in the production cycle so that we can see something actually happening.
Yep.
I'm already lost. You could kill me now and nobody would know. You could bury me under the building and nobody would have a clue where it was.
Well, it'll only depend on how well you edit me in.
Fantastic. That's awesome. I think we're gonna get along just good, man. Jeff, what's your title here?
So I'm the technical manager for product components, the film formulation, quality, and commercialization.
Wow.
So my technical team is responsible to make sure the film works right.
So you also do quality and control. Oh, I like to look at this. Oh, wow.
This room is obviously, it looks like, the mothership part. All the controls in this building get at least initiated from this group here.
How's it going, guys? I'm Destin.
Bob and
Santos, nice to meet you.
Nice to meet you.
So these two guys are our coding specialists. And what we're going to do is in 15 minutes, they're going to do what we call a start. Right? And so in this film, I believe it's about 12 layers.
Yeah, I got 8 layers at one.
You got 8 layers at one coder and 4 or 5? All right. So that's a typical consumer film, in this case, Ektar 100.
You got it.
In this room, they control the operation, but when we start, we're going to see up on these monitors are looking at Coder 1 and Coder 2, which you'll see in a second. And it's an infrared camera that will look at the film while it's coding to see if there are any physical defects showing up. But we look at the left edge and the right edge and the center.
Oh yeah, we're ready to go.
Shoot. All right. I should have cut it short because I know how much time they need.
Sorry.
That's not you, it's me. So just so you know, there's a Coder 2
Okay.
and Coder 1.
Oh my goodness.
And come up here really quick,
Okay.
and you can see the hopper slots.
Yes.
The water is running down.
The door open.
Okay. The door is for air balance, and we'll talk about that when we start coding.
Yeah, we're off the curtain, I'm sorry.
Okay. Are
All right. You hear tension on, which means they're getting ready to code. And we'll talk about the floor here in a
We're gonna
second.
have to go through a light box.
Can I get close?
You can get close, yeah.
And I'm not going to see anything because they're going to cut the lights off.
No. You'll see the colors start. So,
Where is it flowing from? Left to right?
it's coming from here, through these, and it's coming underneath.
Okay.
It's a center-fed hopper. And we're only using a portion of it.
Is it flowing this way?
Nope, it's coming from the time it's dropping.
Okay.
And we'll talk a little bit. So you yell when you need to get in here.
You'll see it flowing.
You'll let me wet?
55 minutes from now.
Okay. all
Okay.
right. So let's keep
Can I
talking. Yep,
ask a question?
Yep,
I'm
yep.
noticing we have laminar flow here.
Yep. So stay back a few inches.
Okay.
There are things that we don't want to disrupt. All right.
Or drop anything in.
You definitely have laminar flow.
We
That is all why it works.
laminar flow is what makes this work.
Right.
Awesome.
But the issues are that when we design the films, the viscosity of the bottom layer and the top layer are key to keeping the different layers from intermixing. What you're going to see happen is at Coder 1 is the bottom half of the pack. And what we haven't told you is this is approximately a mile-long process.
Wow.
Okay? Underneath here, this hopper will slide back and engage the web that's underneath. You can't see the web, but you'll see it when we're in the coding room.
So if I understand correctly, we've got different chemicals coming out from each of these slots.
Different layers.
Different layers.
The layers could have 5 or 6 different components. The components could have 10 or 20 different chemicals.
So if I see correctly, that slot right there,
Yep.
there's fluid coming out of that slot.
Water right now.
And so this is a fluid process.
Whoa, the whole thing is liquid. So this can coat 54 inches wide. On acetate, we're at 45 inches wide. Okay.
I'm going to try to get this right, and you tell me what I mess up, okay? We have liquid that's flowing out of these slots. There's a bunch of little bitty slots here, and I've got liquid flowing over. And if I can control the flow rate of each liquid that's coming out, I can keep them in layers.
That's right.
I can keep them in layers, and so you have to have laminar flow to do that.
Right.
Because if it mixed up and got turbulent, you would have like...
You'd have no color separation, the images. You'd still get an image, just wouldn't look right. All right. But yes, we keep laminar flow.
So that's the secret. And so I can actually see that. I won't mess the process up here. So what I'm looking at right here is...
Oh, watch your finger there.
I will not touch anything. What I'm looking at right there is a stream of liquid that looks like one uniform waterfall, but it's actually a series of waterfalls in parallel.
Exactly. And by the way, when you do a curtain hopper, What will happen is, as this moves back, the roll will be ready underneath. This pan, you will see a pan in the other room when we go infrared that's catching everything. And it will pop out of position very quickly and then drop about 12, 14 inches as a curtain. Now, if you pour any liquid out of a jar, it necks down. We can't have that. It's got to stay absolutely laminar all the way down the sides. We have some guide wires that help, but that's one of the important steps of our curtain coater.
Will you show me the guide wire? I see it. So on the edge there, right there, so that keeps, when you say neck down, you can't have the liquid neck down this way.
Right. As it starts, you'll see various flows that aren't laminar as it gets started. You'll see the colors not being lined up. They'll slowly get better, and then Bob will be going through with a pick to make sure that there's nothing stuck in the slots.
So Bob, you're the expert at making sure the flow is correct.
Yeah. You'll see when it's happening. It's going to start
Here it
happening
starts.
now. I got to get in here.
Yep.
Where do I need to be?
No, take your time. I got to get in there. I got to form a meniscus in the back here.
Hey, Destin.
Yes, sir.
We're going to move to the next coater.
Okay, can we let him finish this real quick? Or do we need to go right now?
He seems okay with it, so you can stay.
So we got another minute to go for it. Don't start. Just for the left. Yeah, we're 800 feet out, so we're fine.
Where do you want me? Is it okay to stay here?
You're good. We're going to move quickly through a rolly door.
Okay.
All right, we're going to head to the other coater because he's going to get ready to close the shield.
Got it? Jeff, I don't think me and you can both fit in here.
I can guarantee you that. I'm lucky if I fit in by myself, Destin.
I like you, Jeff. Boom, okay. So lights are on. This is great. This is awesome. Forgive me, your name one more time?
Santos Roman.
Santos.
Sometimes they start at the bottom, and you can see the first layer, second layer, third layer, all the way up. It came out all either at once or the top went first. So that's why it all looked magenta. So you kind of lost some of the wow factor of seeing it coat.
So I need to be ready.
You're not going to see color here because this is just the yellow pack.
Okay.
So this is the top of the film plus what we call the SOC, the overcoat, which has matte beads in it, some of the chemistry that's necessary, but it's going to happen really fast.
So where do I need to be, Santos? Can I be right here if I don't touch anything?
Yeah, right there. Okay.
Am I good here? There's the yellow.
There it goes.
Santos, I'm seeing little bitty streaks and I can actually see the turbulence in there.
Hey,
Yeah.
there you go.
Just keep watching because it's
Keep
still
watching.
flushing water out.
Yeah, right now it's still unstable. And then I'm going to wait for the last, you can see a little like a blob. There it comes. Now it becomes stable. See?
It's stable.
Now, see all those little lines out?
He's going to get rid of the streaks
Now get rid
if
of
you
those
saw them.
streaks. Now go in here what they call, using
You're wide.
Thanks, Bob.
just like this.
And what are you doing here?
I'm setting up the backlight, the meniscus they call it.
Uh-huh.
Just make sure everything's nice and even on both ends.
You're making sure the waterfall starts cleanly.
Yes.
Okay.
Well, the product itself, no. Now it's what's called slot sweep right here.
A slot sweep.
Yeah, you're injecting the material inside the slot to get any little form object that's exiting the slot itself and going from left to right or right to left.
Oh, I can see it.
See it?
So you just created a separation of the boundary
Yes,
layers.
That's correct. Again, it's really important just to make sure that, and I'm doing a slight twist on it, front and back of it, just to make sure there's any foreign object that's exiting out, that we're getting it.
Are you twisting it this way or
Yeah,
that way?
This way, this way. So now
Okay.
here comes the wooden skewer. This what I do is make sure I'm prepping the lip. Just stick it just like this. Left. And then nice and slow.
So this is creating the separation.
A true even wetting line across the board. And I just separate like that. And now, my final check. See?
I don't know what you're looking for.
Okay.
He's looking for nothing. He's looking for a smooth
If
surface.
there's a disturbance, it'll be like this.
All right.
But it's good. So I gotta see, I go like left and right. So now it's nice and smooth. So now what I do is I close what they call the zone door.
To keep any airflow to it, but
Yeah.
disrupt it. All
Keep a
right.
nice air balance, and then I hit pre-coat. Now she's moving.
What just happened?
What it did is this prep truck drop. Now it goes to the halfway point. It's called pre-coat. It sits there,
The hopper's moving back.
right back. Now, I gotta turn off the light now.
So about to go dark
You know
in
what?
here?
Yeah,
We'll
it's dark.
Okay, cool.
So we can't see our way
So I
out.
need to get out of here so my camera doesn't mess it up,
Yeah,
right?
yeah.
I'm holding on his shoulder here.
Yep, I got you. Okay, this is great. So Santos has this arm on my shoulder.
All right, I'm sorry, I don't know where I am.
That's all good. Oh man, that was so good.
All right, that's the first time I've done that in the dark.
Okay, that was great.
He waited way too long.
I waited too long.
No, Santos let us stay in too long.
Oh, I appreciate that, Santos. Thank you, man. That was great.
So the pan is already pulled out.
Okay.
We missed the pan.
That's
right?
that's cool. I got to see laminar flow. I'm
Okay.
happy. So we put the fluid on the backing.
Support, yeah.
Support,
yeah,
thank you.
yeah.
So we have a laminar flow waterfall that goes down and hits the film at a radius.
Yeah, you can see that there.
And that where's that at?
So here's the curtain.
Uh-huh. The curtain is liquid.
Yes.
Okay.
And it's staying wide. And then this roller here
Uh-huh.
has the support on it.
Okay.
And it's coming towards us. Curtain falls on it. And it's going to go turn upside down.
So that little rod right there is a roller.
It's a roller.
Okay.
And the support is on top of it.
Okay.
And we're coating the layers.
Got it. That makes sense. And so we have I had no idea this was a liquid laminar flow waterfall process. You don't know this about me, Jeff, but I really like laminar flow. It's a thing.
Okay, all right. Well, I'll use the term from now on.
Okay, I kind of see what's going on conceptually with the hopper, but I don't really understand it. So it wasn't until I went to the area they called the museum and Jeff laid the parts out in front of me and started to explain it, that's when I started actually understanding what was going on.
We start with a solid, and we melt it and create a liquid. We begin pumping it into now a pipe and a hose, and we combine the various kettles together that need to be combined to begin to form the entrance for a layer, and we come to a hopper. And this is one of the hopper bars, all right? And it's solid titanium.
This is solid titanium?
Yep, try to lift it.
That's the heaviest piece of titanium I've ever seen.
And
Which is pretty lightweight.
And we use titanium for the thermal stability.
Okay.
All right, and dimensional stability, those kinds of things. This is just one. So the hose that comes out of here will feed this hopper, come through this hole,
Wow.
fill the slot.
And this is polished. Can I touch it?
Yeah.
Yeah, that is a polished surface finish there.
Fill this slot, and as you see this geometry, you can see the side of this here.
Okay.
So each one of these.
And this is the coater.
This is the hopper.
This is the hopper. Okay.
Coater, hopper, yes.
Same thing. Okay. So basically, we mix all of our melts together. We mix our chemicals together, and we get them ready to put in a layer. We go into here, and it comes out right here, and that creates a solid amount of pressure all the way across here.
Exactly.
And then how are we going to squeeze that out?
Well, the spacing, which are kind of hard to see here, there's, if you drag your finger, you'll feel low, higher,
Okay.
and
so,
higher. So once this is full, it'll go this way.
Okay.
Once this is full, it'll come out the hopper.
Gotcha.
And these are staggered.
Okay. Got it.
So this fills the slot, puts a population in it, because one of the things we don't want is any agitation, any pulsation where too much comes out. So these are like micro reservoirs. And then eventually it comes out, in this case, 7 layers for this
So
particular
this
hopper.
flow rate is really low, and you want it to be very, very, it's a sheet flow, very laminar.
Exactly. This surface here is the surface over there. And so it comes out here and then goes off this way.
Okay, so I can feel that it's stepping down with
Yep.
each one.
Yep.
So that makes sense. So as it flows here, the next layer would flow on top of that. So it kind of just sawtooths up.
Absolutely. And so this is where the other big side of chemistry and our ability to coat comes in. By controlling the viscosity, by controlling the amount of gelatin and water, we can keep these from intermixing.
You are changing the properties of each layer just enough to make it different from the layer above it and below it that they don't mix.
I wish it was that easy.
Okay.
But the fact of the matter is the ones we really have to control is the top, because there's a water-air
Boundary layer.
And those are more, dangerous is the wrong word, but more impactful on the flow. So the bottom layer.
They're unstable.
Very good. The bottom layer and the top layer are the ones we have to control the best.
Got it.
As long as the inside layers are not hugely different in their viscosity and their other properties, it usually holds together.
Okay.
It isn't like we have to change every...
Because you have a liquid-solid interaction down here.
Yep.
And you have a liquid-air interaction here. So it's those boundary conditions that you wrestle
Yeah,
with.
and we can say liquid-solid, but remember, this flows over the edge and falls.
Got it.
So it will be an air-water on one side of the curtain and an air-water on the other side of the curtain.
So it's a laminar waterfall with a pocket of air behind it.
Yes.
So how do you control the air behind it? Is it atmospheric pressure behind the waterfall?
There's actually a little vacuum.
There is a little vacuum.
Yeah, I didn't point that out yesterday, but it's tough to see. But when there are issues with coating, they'll play with the vacuum conditions. I pointed it out, the WEGs, the water edge guides, those wires down the side. Those help us to maintain the curtain as it falls.
So you have guided laminar flow. Guided laminar flow. That's what you're doing.
If this didn't have the edge guide, it would still neck in.
Yes.
Just like any, because gravity's going to do that.
Got it.
Okay? Surface tension is going to do that. By pinning it to the outside, and we use that little wire with a little water on it.
Surface tension.
Surface tension.
Does it mix out there with the wire and the water?
Good question. I wish I could answer you.
I think
we don't care, because out there is going to be cut away anyway.
Okay.
But it's got to.
Yeah, it's got to.
You know what? I'll ask the smart people.
That makes sense.
Yeah.
Jeff went and talked to the mechanical engineers that work with the hopper, and there are some incredible things about this design. For example, they have to control how parallel those bars stack up to within 50 millionths of an inch, which is an incredibly tight tolerance. There's tons of interesting fluid dynamics things to think about as well. Look right here, for example. As that fluid comes up through the slot and turns to kind of get in line with that laminar waterfall, I like to think about what's happening right there. Like, how is it making that turn without mixing up? There's something really interesting happening there. I just don't know what it is. Also, think about the interface between the metal and the bottom layer and the air and the top layer. The rest of them are kind of all moving at the same velocity, so I can imagine that, but I wonder how they take that into account. There's a lot of fluid dynamics happening after the waterfall falls as well. First of all, how it separates from the lip, that's probably a science in and of itself, but think about the fluid that's falling. It's accelerating on the way down, which means it's thinning out, but the support itself is moving faster than the waterfall is falling, which means it thins out even more. So you have two different thinning sections, the fall and as the backing or support accelerates away. This is really interesting to think about.
So what we're doing is they're going to start the coating one more time, and I've asked if we can try to capture that laminar flow waterfall one more time, because I didn't do a great job to begin with.
Right now, 1,200 feet, here it comes.
Here it comes. Gotcha. So you got streaks.
It's a transition from copper flush to product. Now it's actually coming through more and more and more, denser and denser, concentrated more.
And so we're getting to a steady state waterfall now, right?
Right now, now I walk in.
Yep, do it.
Take care of the meniscus, the backline right here. Make sure it's nice and.
Oh.
Then I go both sides. So now I go slot sweep.
Slot sweep?
Yep, this is what they call slot sweep. What it does is you're putting a foreign material inside the slots so to get any particulate that's coming out of the exiting slots. If it gets stuck on the edge, it knocks it out. And I'm actually slight twisting it. So it's getting front and back. So now I'm done with the last one. If I throw this out, now this is what we call prep the lip. Get a wood skewer.
This is the magic wood process.
So you go like this, in, left, and then slow from left to right.
Sorry about the flash.
It's okay. This will now go in. Now your camera is slightly in the way. Okay, so now I just go on like that. There's no imperfections left or right, and right to left, nothing. Everything's clear. Put the zone door down to keep the air balanced. You can hear the 3 blind mice. 3, 2, 1. It means I have to send it out. So now with this process right here, you can see it's going to go right what they call pre-coat.
And do you want to, well,
Keep going.
you know your way out of it.
At the same time, see the start finish paint's arm.
Yep.
And I look, and it's going to go automatic, and I'm going to darken down very shortly.
All right.
If you want to go out and see anything out there, well, you might not.
Yeah, that sounds good. So you're gonna cut the lights off and then we're gonna walk out, right?
Yep.
Now that we know about the hopper, I want to go back downstairs and see a couple of things Jeff had showed that I think you'll find to be really interesting.
This is the pedestal. Remember when I was showing you the hopper and I pointed at the floor?
Uh-huh.
So the floor floats on this.
What?
That floor holding the hopper up there, both hoppers, sit on this pedestal, which goes to bedrock.
Oh, for
No
seismic
trucks.
stability.
No trucks driving by, because all of that would cause vibration in the building and it would mean the coating wouldn't be uniform.
So that hopper is so important. You have to have no vibrations whatsoever.
Vibrations, thermal stability, that's all being taken into account. All right? So, you know, I wanted to point out that this is the thought that went into building this building. It's all the way through to the bedrock. I think it's something like 90 feet below the surface of the outside.
So when you're stepping on the ground in front of the hopper, you're
Yeah.
not stepping on the ground near the hopper. Like it's mechanically disconnected.
It was about 3 feet from the wall. There was a metal plate,
Uh-huh.
and when you're on one side, you're being on this. You're on the other, you're on the building.
That's amazing. So they understood that the most important thing in this whole operation is that titanium hopper and keeping it from wiggling and keeping it stable.
It was designed for motion picture films where we wanted maximum uniformity, because again, you've got hundreds of feet of film, thousands of feet of film, and you want it uniform. You don't want density fluctuations for any reason.
That's incredible.
Isn't that a good thought process?
It really
Yeah,
is.
it's a good story.
Okay, now that we know about the coaters, we're going to go back to the beginning of the process. Remember, we have unwind, coat, chill, dry, coat, chill, dry, wind up. Now we're going to go to the unwind phase, and Brian, one of the process engineers, is leading us to the place in the building where they load the big blank rolls of film into the machine to begin the light-sensitive coating process.
So we're going to splice from this roll. This is what they're coating right now. When the diameter gets small enough, this is going to shut down and stop. This has a tape on the top. There's a knife underneath, some clamps. It's going to come down and clamp the support, cut through them both. It'll flip over, tape the two together, and then it'll start up and take off.
Let me get this straight. We've got a roll right here,
Yeah.
and it's waiting.
So right here they're cutting to it. So here they're going to put tape on it. That rolls. So now so we got to the end of that roll, and now they're splicing this. Leader is going through the machine, and then we'll have an AGV come in. We can walk out here and watch an AGV if you
Let's
want.
do it. What is the AGB?
So that's an automatic guided vehicle that will carry our support rolls around.
Okay, so I got a robot coming at me. Got
And
it?
that'll stop. That'll stop there. So you're
That's
okay there for now.
Okay.
So you can get back in. So you can come in here. That's going to stay there. So this is going to go in and load up and chuck up here. So you can see it from in here if you want. If you want to.
Okay. So this is an autonomous vehicle.
Yeah.
Can I stand right there?
Sure. Yeah.
Okay.
And so this goes in. You know, it lets the unwinder calls for it and says, "Hey, I need a new roll." This brings it in. It's going to load up. It's got a little positioning things, senses when it's at the right spot. Now those chucks, the spindles, you see those go into the roll?
I see
into the
it.
core. So those go in. They actually come back out and rotate. They want to make sure they set those, the spindle, the cogs into the spindle there so that it'll drive it.
Okay, so I've got a large roll, an autonomous robot. Just
Yep.
put the roll in position.
Yeah.
It indexed on the sides, and then
Yeah.
it put the spindle in.
Right, that's going to come out now. It's going to come out and go through that door.
Okay, so I need to be this way.
Yeah, so this is a light lock door.
So just to let you know, there's an exact same copy of this on the other side of that door which takes the coated film.
Yeah.
Got it.
So this will go over to the winder side.
So
but
now
you
we'll go
can't
in that
see
dark
it.
area. There's an unwind. So on the other side of that door, that empty AGV was going to go pick up a coated roll.
Got it.
And when we say coated, that means it's got the photographic stuff on it.
Yeah.
Stuff. I believe I
Right.
just said that?
Yeah.
So what I'm seeing right now, let me just say what I think I'm seeing, and you tell me
Yeah.
if this is correct. So that's the coating process. The splice has happened,
Yep.
and then I've got this roll right here that we're feeding
Yes.
that.
It's going in through the machine.
We're accumulating there. Is that a new?
Yeah. So he's getting another roll ready to be spliced to.
So the first assessment stop is now was at the unwinder. Samples will be taken and sent to our testing group.
Got it.
If it's go, so the other people in my group over in the other building are looking at it probably in about 45 or 50 minutes, and they're going to determine whether it's good enough to sell. And if so, they're going to start coating again.
So you're, if I understand correctly, we just did the first run of the day, and we're going to take that film that we made, and we're going to test it. So somebody's going to expose it in a certain way.
Yep.
They're going to look for defects,
Yep.
and they're also going to look for the proper exposure levels.
The sensitometry, that it covers the right exposure levels for the product. And if it's off, we'll make some corrections to flows of chemicals, and we're rarely off, but
Yeah.
this is an important
Yeah.
product, so we check it.
Hectare, yeah.
Yeah. So if it's fine, it'll go and we would see the same thing that we just watched. If not, we'll make corrections, make flow adjustments, and do it again.
That's awesome.
This one down here is a leader. It's between a coated material and then it fills the machine with non-sensitized material.
Got it.
So that when we start again, you don't have to rethread the whole machine.
Oh, I see. Got it. It's like sticking a string through the hole
Yes.
so you can
Yep.
pull the big. Okay. got it.
Exactly.
So we're going to shut down when this gets down to a small enough diameter. And like I
Correct.
said, we're calculating the diameter based on every time that makes a rotation, we're looking at how much footage came off.
Are you measuring the diameter in real time?
Yes. Then we also figure out how the diameter changes, how thick the support is, so we know how much footage is left on there. And we say, okay, we get to a certain amount, it's like it's time to start slowing down so we don't pull the end off of there.
Gotcha.
Okay,
Wow.
we have another AGV is going to come through.
Okay.
It's getting called over to the winder. We can stop it. The bumpers will stop it.
Yeah, but I don't want them to stop because of us.
Yeah.
So how long have they been using the AGVs to load?
They started those in 1990. When they built the machine in 88 or 90.
Oh, so it's
yeah,
always
yeah.
been like this?
Yeah, right.
Oh,
those,
wow.
those are the original ones, right? Yep, for this.
And they're wire guided in the floor.
Oh,
Yeah.
really?
So it's
Right.
radio, but they're wired.
Yeah, it's radio to tell them where to go and everything. But right.
So
There's
it's following some kind of
Yeah.
induction path.
Exactly.
Right.
It's
yes,
awesome.
Right.
This is awesome. This is way different than I expected. I don't know what I thought, but it's not this. This is great.
Yeah,
So-
you have to piece this together. This is like a small part of the mechanics of moving support around the machine.
So we've seen the unwinder and we've seen coating. Now it's time to see where the wet film goes once it comes out of the hopper, and that's the chiller.
All that stuff that they're coating, we got to set that pretty quickly. We can probably see it better here. Let me just,
So the arrow means that the film flows that way.
yeah. Right, yeah. So in here, and we can go into the other section, but so we've got cool air blowing out of here. The coating is on the bottom here. There's cool air blowing out of here to cool the support down.
Oh, wow.
But then there's air getting sucked in from the edges to suck everything back
Brian,
up.
you just got paged.
What?
You just got paged.
All right.
What's happened?
He's getting called. Just-
Oh, okay. Got it.
So let me just try to. So the film's upside down in this section.
Okay.
All right. So we're right off to the side there. It's the top of the hopper. It comes down that curtain, hits the web, goes upside down and into this room.
Got it.
And it's changing a liquid to a semi-solid. Once it leaves the coater, everything else is conveyance. Chilling and drying is setting the film. preparing it for being able to be handled. So everything prior to that is coating.
You're really good at this. You're really...
Lots of years.
Yeah, they're not ready. They're not starting yet.
Okay. So are we going to be touching, when this is actually rolling, are we touching the film?
No, nothing touches, from the coater, again, nothing touches the emulsion side. The actual film, the coating, nothing touches there. This is just blowing again on the support on the back side of it that doesn't have any fresh coating on it.
Gotcha.
So we've applied the gelatin-based emulsion to the support, and we've solidified it in the chiller. Now it's time to pull the excess moisture out of that emulsion. And the way we do that is with the dryer. And as you can see here on the 3D animation, the bulk of this facility is dedicated to drying out the film.
It takes a lot of air and a lot of time to dry all that water out of it, and we try to do it. We can't just dry it at real high temperatures, or that affects the gelatin structure, which can affect the sensitometry and a few other things. We'll come in here and I'll show you one of the sections and one of the turning bars.
Crossover entrance.
So here's a dryer. We'll start with a dryer section towards the end of the machine. So there's dryers on both sides here. So here's where the support, would be coming through, and we can't have there's no contact on the face. This is blowing dry air on it, but it's relatively cool, in this section, it's between, we get the dew point way down low so we can pull moisture up, but, and as we're pulling the web through, these air bars are floating it, and so this is just kind of floating here.
So this is not touching anything?
Correct.
So film is coming in from way down there. It's coming all the way down here, and along the way it's being dried. And I've got to show you this. So this is stainless steel, and they have little ports in here. And I'll just let you hear the flow. So check this out. Here's my microphone. See my microphone? Feel this? All right, so you can't tell, but that's a lot of airflow. And so Brian, if I understand correctly, you're saying that it's riding all the way down this almost like an air hockey puck.
Right, yeah.
And so these are keeping it elevated, and
right.
This is blowing down.
Yeah, to dry it, correct.
How do you make sure you do that balance correctly?
That takes, it took a lot of trial and error initially.
I was hoping he was going to say that.
Yeah?
It's trial and error. I mean, the amount of water changes. So there are different drying conditions and air balances for each film that we use.
So do you have like a needle valve somewhere that you're adjusting?
Probably a lot more sensitive than
yeah,
that.
right. I mean, there's big fans that are blowing all this air out, and they all have variable frequency drives on them, so they can change the speed of the fan to change the pressure.
So when you open this up, that's to service this?
Yeah, right. Yes, if they need to clean these off, especially if they have a tear off or something, you get emulsion all over the place, you got to clean stuff, they have to drop these down. So, right, you can open these up and they swing and they'll drop down.
So Jeff, if I have a break in the film in here, will I just get a big pile of film in here?
So it depends how fast we stop the web from moving. So when it's coating, and right out of the coater, it's wet, and then it's going to fall off and make a mess.
It could just pile up in here and you have to come clean it out.
But if this moves, say 20 feet or 100 feet, it's going to scrape and scratch, and it'll delaminate the film part of off the support. And yeah, you're going to come in and clean it up.
That's amazing. All right.
Yeah.
Thank you very much. So this is one of several drying halls.
Yes, right. In the first dryer, we have about 4 sections like that, and then we have another 6 like that.
So each of those long runs
after
in that map is one of these hallways.
That's amazing.
Right. So now we'll go to an air bar. So after we come down here,
I want to discuss that, Jeff. So we have air blowing down
onto the film.
So that's pushing it down.
Yes.
Right.
Which is the reverse hockey puck, air hockey puck. And then you've got the what do you call it from the bottom? It's basically...
That's called an air bar.
Air bar.
It's the conveyance part of it.
But and the So the reason we were able to do that with the air bars, the older machines just had a flat plenum with holes in it, and then you need rollers behind it. The air bar can push it up because you notice those were corrugated.
Yeah.
So even though it's blowing a lot of air on there, after the air hits the support, you know, it can go up into the corrugation, and so it doesn't put a lot of, and it can get out without adding a lot of pressure to it.
And again, it's conditioned air, so what you're trying to do is move water off the film and take it away.
That's the whole point of the hull.
Yeah.
It's to dry it and pull all that water out.
It occurs to me that you're blowing a tremendous amount of air into that room.
Yes.
And you're trying to get it out somewhere. Is it at the other end or?
Well, there was a big exhaust duct here you can see here
Okay.
where it's going out. There's a big grate right there. So this is sucking it out, going out to an exhaust. And some of it, so this will be, this is pulling all the air out of there.
Got it. That's a lot of airflow.
Yes.
So you can see in the dryer, we went to great lengths to not touch the film. We're hovering it on air, right? But you'll notice on the model here that we're actually turning the film in locations, but we're still pulling it, meaning we maintain tension on that. How do we turn the film without touching it? The way Kodak accomplishes this is fascinating.
So after it comes out of there, now we got to switch and come over here. So that's where we have, and actually I'll show you that other.
Okay, so we're going parallel here.
Yeah.
We're going to go up and over and down into here.
And I'll show you the turning bar here.
Oh, and that's the arrow that tells where it's going.
Yeah. So this is a turning bar here where we, this is where it's floating over this here, you know? So this is how we make that turn.
So let me get my frame of reference here. So I'm coming this way, and then I'm going up over here,
Yeah.
and then I get here, and I go over and down, back to this roller, and I turn 45 degrees, and I go that way.
On the turning bar, right. There's another turning bar over there. You can see it right through here, probably, you know. So, right, we're coming out around there, over.
And then that way. So,
Right.
question here, may I step on this?
Yes.
If I don't
Yeah.
touch anything?
Yeah, don't bang your head.
Okay, I'm looking up, big my head. Okay, so I'm seeing a hole right here.
Yes. That's not, that is actually looking at the feedback pressure. That's looking at how much pressure it takes to float the support on there. And we can use that to sort of as a secondary tension calculation to make sure our tension measurement, tension control is working.
Can I touch right here?
Yeah, you can, these holes are blowing air out.
Oh, it's really far off.
Yeah, and that's blowing air, you know, in behind the web there. So, and these are a little wider to hit.
So that's like 1/8 of an inch.
Yeah.
We'll get in real tight here. So right here. So if I understand correctly, Brian, air is flowing out of these.
Yep.
And then this is an inlet. Is it a static pressure?
Yeah, it's just going to this. This sensor is going to a little pressure transmitter. So this is just looking at how much air pressure is right under the support in the middle there.
I just realized something. This doesn't roll.
No, this doesn't move.
This doesn't move.
Well, it's
That's
actually,
amazing.
it does move. Now, here's another feature. So in order to keep the web centered, you know, for these long stretches, so we recenter it here. So this actually moves back and forth here. I can,
I got you. You have an actuator. So is that a pivot point over there?
I can slide it, have it move a little bit.
It's more for steering.
So this is to steer the web. We have sensors that are figuring out where the web is. So this whole thing,
This is so completely awesome.
so this thing here will move, it'll move back and forth.
Oh, are you moving right now?
Yeah, right. So I can move it the other way.
All right. And so is that translating the whole thing this way and that way? Or is it pivoting?
So that changes as the web comes in. That's going to change where it comes off of here to move it north or south so that it stays on center in the machine. those little sensors there have ultrasonic sensors in them, those black things.
Right
And
there.
they can detect where the edge of the web is.
So those are proximity sensors looking down.
Yeah, they're looking through it. It's a little ultrasonic thing. I mean, we can't use anything with light, so those are looking through the support, and they can tell where the support is and where the air is. And so we try to keep it centered between those. And this will move back and forth to center it.
So if I understand correctly, the film's going down that hall over there,
Yeah.
turns on the turning bar, comes up right here
Yeah.
over the top, down here, and then goes this way. You have the ability to move this whole bar this way and that way,
Yeah.
and that repositions it down the hall.
Yeah.
Do I have it?
Yep.
So what are you doing to, like, if you have to bump it one way or the other down the hall, how do you move it left and right?
So it's using those sensors that are going into a PLC, a controller, and this actuator right here, there's an actuator here that's driving it. There's a little motor here.
So it's an electromechanical actuator.
Yeah, right.
And so it's a closed feedback loop system
yes,
while it's running.
yes.
That's amazing. I don't know why it's so amazing to me that that thing doesn't roll, but it's a little
Right.
mind-blowing.
Yeah.
Okay, so at this point, we've seen pretty much all the processes. We have unwind, coat, chill, dry, and then with the second pack, they would just do all this again. Coat, chill, dry, and then you wind it up. One thing we didn't talk about is the fact that they test the heck out of this stuff. They have a raster scanner that will scan all the film looking for dirt and stuff like that, and actually creates a digital map, so to speak, so they can find out where the dirt spots are in the film. They also have sensitometry testing. They'll actually develop the film, and then they test it in this really cool quality lab. I'll put all that over on the second channel so you can check that video out because it's really, really interesting. So at this point, the film has been light sensitized. Let's see what happens after the completed roll is obtained and taken to the next step.
Once we are done, we package them in here and put them to finishing. Finishing is who is going to slit and perf and prep the film, box it up, and ship it out. So this is our ASRS, automated storage roll system. There are two alleys, and there's an automated machine that goes up and grabs the rolls out of storage, brings them in here, and then they're either taken to where they need to go, or they come off of here and we load the system. We're gonna go upstairs. You'll get a much better view from up down.
Let's do it.
All right.
The support rolls come in these boxes we call caskets, film caskets, you know, and so they come in here on trucks and they load them here with a fork truck, and from here they go into the machine and get stored, and we can go see where they store them. This part isn't used over here anymore, and then watch yourself here. It's
Sure.
kind of tight.
Wow. Okay, you're absolutely right. This is the place to see it, isn't it?
So we're at the upper second floor from where it was when we were down below. So you got these two alleys with automated vehicles that can lift these 2-ton rolls.
Yeah.
And they're stored here for either coming in or getting ready to ship them out.
So you would know, for example, like you would say things in your computer system, you'd say, casket 55 has the first coating for...
Has the first roll of Ectochrome,
Yeah,
and it's stored in level whatever, bin whatever.
So this knows what the location is. You know, they put in the ID, the roll ID. This will pick it, grab it, and it'll take it and put it on the conveyors, and then it'll go out into the machine where they unpack it out of the box, put it on an AGV, goes the unwinder, then it gets wound, you know, it gets coated and dried and wound up, goes back into a box, and now these boxes have to be light tight because now it's all light sensitive stuff there. And then they send it back into storage, and it scans it on the way in, stores it here, and then when the truck comes, when they want to send it out to finishing, they'll call out the roll and it'll bring it out to the dock and they'll load it on a truck.
Something that is occurring to me is like these caskets are filled with film, and there's an incredible amount of human memories that are going to be captured. Like, so the film that captured the Apollo stuff maybe have gone through these caskets, or are they quite that old?
Oh, easily.
Really?
Because,
I think
yeah, some of these caskets would
are
have been
from the old
back
29
then. They
machine,
wouldn't have been made in this machine for
Yes.
Apollo, but they would have been made in the next building over. When
So we are at the bottleneck point of human memory for all of history in terms of a lot of the historical photos. I mean,
Oh, absolutely.
That's
I mean,
incredible.
if you want to look at historical photos, yeah.
so when I used to work at some manufacturing facilities, I felt like seeing the product roll off the line was just really satisfying.
Yeah.
It's like, hey, we made something today. Do you
So-
guys get that same feeling here?
So, I almost should say cut here. No, and the reason why is it happens all the time.
Oh, I see.
So it happens in the dark.
oh.
I get satisfied when at the end I see the sensitometry and I look at how good the quality was. So I'm sitting at my desk or my computer looking at the results.
And you get the result.
I mean, finishing, when you get over to finishing and you see thousands of these coming out per minute, that's kind of satisfying.
Okay.
So we're part of the chain. Am I happy every time we have a roll? Yes. When we make changes and it works, absolutely.
But for you specifically, Jeff, your product is quality.
Yes.
That's your product, and you're handing that over to the finishing people.
Yep.
And they're going to turn it into that.
Yep. These master rolls that you saw us moving around on the unwinder. Yeah.
That's awesome. Jeff, this was awesome. Thank you very much, man.
My pleasure.
We really appreciate it. We felt like we know a lot about film now.
You guys were an excellent tour. Great questions.
Trent, what'd you think?
Awesome.
So
much.
And we did cover a lot. I know there's a ton more to cover, but it's pretty good.
thank you so much. We enjoyed the tour here at Kodak, Rochester, New York. This is amazing. We appreciate it.
Yes.
And Matt, thank you for everything you did.
My pleasure.
I appreciate you holding everything.
Absolutely my pleasure.
This is awesome.
Before we wrap up here, I just want to point out one thing. You will notice there is not a sponsor on this video. Kodak did not sponsor this. No money exchanged hands. I just want to thank the patrons of Smarter Every Day for helping me do this. You support on Patreon, and I'm grateful. People that do support on Patreon, get one of these. It's a baseball, a Smarter Everyday baseball, and everybody who supports on Patreon gets one of these. It's the first thing I do is I send you a gift to say thank you. So if you would like, I don't know, it's always weird asking this, but if you like this content and you think it's worth your time and you want more of this kind of thing on the internet, please consider supporting Smarter Every Day on Patreon. There's no sponsor on this. Patrons make it possible, which is a really big deal. It takes forever to make these videos and to pay for animations and all that kind of stuff. So I'm grateful for people that support on Patreon. Please consider doing that at patreon.com/smartereveryday. But we are at the second of the third videos on Kodak. So the next video, we're gonna take this light sensitized material out of these caskets and we're gonna chop it up. We're gonna there's a thing called a slitter. It's very interesting. And how do these holes get put in the film? You will see that in the next video as a part of this 3-part Kodak series on how film is made. I'm grateful to everyone who supports Smarter Every Day on Patreon. Thank you so much. You actually make this content happen, and I'm grateful. Thank you to everybody at Kodak that allowed me to tour your facility. Remember, there's 2 videos on the second channel for Smarter Every Day. One of them covers everything about film chemistry. The second video is about how Kodak controls the quality of the film during the manufacturing process. Don't want to miss those if you're into this stuff. They're very interesting. That's it. I'm just super duper grateful, and I hope you enjoy the process of film photography as much as I do. I will leave you with a photo, and I hope you enjoyed this as much as I do. Oh, I had my shutter set wrong, so that's gonna be a blurry photo. I wasted a piece of film. That's okay. We're gonna make more in the next video. Anyway, that's it. I'm Destin. You're getting smarter every day. Have a good one. Bye.
So one of the things you asked me to do yesterday was our rolls of, how many rolls of film can we get
Right.
from one of these master rolls?
Right.
60,000, and I was right.
60,000 from one master roll?
So this is about 7,000 feet long by 45 inches wide, and we can get 60,000 of these
Okay.
for a 24 exposure.
Okay, so these are 5 feet long.
So if this was 3 feet long,
Gotcha.
This would be 60,000 of them.
Understood.
All right. So this is a 36 exposure, a 24 exposure. We get 60,000.
Awesome.
All right.
Sounds good.